What if a telescope just revealed something that challenges everything we thought we knew about life in the universe, and even the structure of the cosmos itself? This isn't science fiction. These are real discoveries made by NASA's James Webb Space Telescope over just the last few months. And the implications? They're staggering. We're talking about potential signs of alien life detected on a distant world, galaxies that, according to our models, simply shouldn't exist, stars behaving in ways that defy explanation, and light escaping from regions of space where it should be impossible. Some of the world's leading scientists are calling these findings totally unexpected and stunning. Others admit we're seeing things that our current theories can't explain. From Cambridge University's detection of gases that, on Earth, come exclusively from living organisms, to massive ancient galaxies that challenge our understanding of cosmic evolution, these discoveries aren't just expanding our knowledge. They're forcing us to question fundamental assumptions about how the universe works. The James Webb Space Telescope hasn't just been observing space. It's been uncovering secrets that might change everything we thought we knew about our place in the cosmos. The wild signal from K2-18b in April 2025, a team of astronomers at Cambridge University made an announcement that sent shockwaves through the scientific community. Using the James Webb Space Telescope, they detected something extraordinary in the atmosphere of exoplanet K2-18b, a world 120 light-years away, sitting perfectly in its star's habitable zone. The discovery: dimethyl sulfide, known as DMS. Now, this might sound like just another chemical compound, but here's what makes this absolutely mind-blowing. On Earth, DMS is produced almost exclusively by living organisms, specifically ocean microbes. We've never found a non-biological process that creates this gas. The detection reached what scientists call a 3 sigma confidence level. In statistical terms, that means there's less than a 0.3% chance this is a false positive. The signal is real. Dr. Niku Madhusudan, who led the Cambridge team, described this as potentially the strongest evidence yet of a biosignature outside our solar system. But here's the thing. Even he's being cautious. The team is calling for additional Webb observations, roughly 20 more hours of telescope time, to absolutely confirm what they're seeing. Independent research teams are already scrambling to verify these results. NASA has greenlit follow-up missions. The scientific community is holding its breath, because if confirmed, we're not just talking about finding life elsewhere in the universe. We're talking about finding it relatively close to home, on a world we can actually study. The Big Wheel Galaxy. But if this planet might host life, what the telescope found next is even crazier. Just weeks before the K2-18b discovery, in March 2025, JWST delivered another bombshell that left astronomers scratching their heads. Deep in space, 11.7 billion light-years away, the telescope spotted something that, according to our understanding of cosmic evolution, simply shouldn't exist. They're calling it the Big Wheel, a massive spiral galaxy that's 5 times larger than our entire Milky Way. But here's the problem. This galaxy formed when the universe was just 2 billion years old, practically an infant in cosmic terms. Dr. Chuck Steidl from Caltech put it perfectly when he said, "Discovering this galaxy was like finding a living dinosaur. According to every model we have of how galaxies form and grow, there simply wasn't enough time for something this massive to develop." The Big Wheel spans roughly 100,000 light-years in radius and contains more mass than we thought possible for that era. Our computer simulations of the early universe predict that galaxies should have been much smaller, still in the process of slowly accumulating matter and forming their structures. But Webb's infrared vision cut right through cosmic dust and distance to show us this fully formed spiral giant, complete with defined arms and a massive central bulge. It's forcing astronomers to completely reconsider how quickly cosmic structures can assemble. Unexpected cosmic spins in March 2025. Dr. Lior Shamir at Kansas State University was analyzing deep field images from JWST when he noticed something that made him stop dead in his tracks. He was studying the rotation patterns of 263 galaxies captured in Webb's ultra-deep surveys, expecting to find what cosmologists have always assumed: a completely random distribution of spinning directions. Instead, he found something that shouldn't exist in our universe. Two-thirds of the galaxies were spinning clockwise. Only one-third were spinning counterclockwise. In a truly random isotropic universe, which is what all our models predict, this split should be exactly 50-50. Shamir published his findings in the monthly notices of the Royal Astronomical Society, but even he admits the implications are troubling. "We do not quite know what causes this," he stated in the Kansas State press release. The bias is so pronounced that it's forcing scientists to consider explanations that venture into uncharted territory. One possibility is that our entire observable universe has a preferred axis of rotation, a concept that would fundamentally challenge the cosmological principle that the universe looks the same in all directions. Another theory suggests we might be seeing the effects of what's called black hole cosmology, the idea that our universe itself exists within a rotating black hole. But before you panic, Shamir and his team are also exploring more mundane explanations. The most likely culprit could be a Doppler bias caused by our own galaxy's motion through space. As we hurtle through the cosmos, the light from distant galaxies gets shifted in ways that might create this apparent asymmetry. It's a calibration issue that could be corrected with better distance measurements. But here's what's keeping astronomers up at night. If this bias persists when they examine other Webb deep fields, if it shows up in data from future telescopes, then we're looking at evidence that our understanding of cosmic structure is fundamentally flawed. Star birth stalled in the galactic core. What happens next flips our understanding of star birth completely on its head. At the very center of our galaxy lies one of the most star-rich regions in the known universe, Sagittarius C. It's packed with dense clouds of gas and dust, the raw materials needed to forge new stars. By every rule of astrophysics, this region should be a stellar nursery on steroids, pumping out new stars at an incredible rate. But when JWST turned its infrared gaze toward this cosmic factory in early 2025, it revealed something deeply puzzling. The star formation rate was dramatically lower than expected. Massive clouds of gas were just sitting there, refusing to collapse and ignite into new stars. The telescope's unprecedented clarity revealed why, and it's rewriting our understanding of stellar birth. Webb detected powerful magnetic fields threading through these gas clouds like invisible barriers. These fields are so strong, they're essentially strangling star formation before it can begin. The magnetic pressure is counteracting gravity's pull, preventing the gas from collapsing into the dense cores that would eventually become stars. But here's where it gets really interesting. JWST also spotted something else: needle-thin jets of superheated gas blasting out from deep within some of these clouds. These are the telltale signs of protostars, baby stars that are fighting to be born despite the magnetic suppression. Dr. John Bally, who led the analysis published in the Astrophysical Journal, described these jets as the first direct confirmations of outflows from newly forming stars in this region. The protostars are there, struggling against the magnetic straitjacket, but only a fraction are making it through the process. This discovery is solving a long-standing puzzle that has baffled astronomers for decades. Why is the galactic center, despite having all the right ingredients for star formation, producing so few new stars? The answer is magnetism, nature's cosmic birth control. The implications extend far beyond our galaxy. If magnetic fields can regulate star formation this dramatically in high-density environments, it means our models of how galaxies evolve and grow need major revisions. The planet that fell into a star on April 10th, 2025, JWST captured something that sounds like science fiction, but is terrifyingly real. The final moments of a planet's existence as it plunged into its dying star. The system is called HD 63454, located about 1,000 light-years from Earth. What Webb witnessed there is essentially a cosmic autopsy, the aftermath of a planetary death that offers us a chilling glimpse into the potential fate of our own solar system. Initially, astronomers thought they knew what happened. The star had evolved into a red giant, expanding outward and simply swallowing the unfortunate planet whole. But JWST's detailed spectroscopic analysis revealed a much more dramatic story. The star hadn't expanded to engulf the planet. Instead, the planet's orbit had slowly decayed over millions of years, until it finally spiraled into a death plunge. Webb caught the aftermath, a hot accretion disk of vaporized planetary material swirling around the star, mixed with cooler clouds of expanding dust and debris. Dr. Ryan Lau, from a NOR lab, who led the investigation, described this as providing unprecedented insight into the final fates of planetary systems, possibly including our own. The implications are sobering, because this is exactly what astronomers predict will happen to Earth in about 5 billion years.